Hello everyone. Yay, thank you. Opening applause, you're putting your trust in me. That's appreciated. I hope I will repay you with interesting content. So I call this talk The Age of Orchestration, and I come up with fancy titles, catchy titles. See, it worked. It's a full room. I'm happy about that. But the point of the talk is to give you a sense of a little bit about where the Docker ecosystem is moving first. I'm going to give you a brief introduction, what Docker is, and then we're going to see what we at Atlassian are doing on the front of Docker, on the product side and internally, in our internal systems. But this wouldn't be right, at the developers conference if I didn't show you a demo of things. So I also want to demo a couple of things, Docker orchestration tools that are coming up, in the previous, that have come up in the previous year. So that's the plan. Before I start, a quick raise of hand. Who has typed a Docker run and run a container already? Has tried it? Okay, it's say 15% of the audience. So for those guys, and maybe you guys were in the workshop yesterday, for those that haven't done it yet, or maybe are here just to understand what Docker is, I give you my 3 minutes brief introduction to Docker. There's a lot to tell, so I'll try to be brief so that I can tell you more about the orchestration stuff. But if you want to know more, you want to talk me through problems, or you want to chat about Docker, you can always find me later. So to understand Docker, most people always contrast Docker and containers to virtual machines. So virtual machines have taken over, cloud deployments, cloud applications development, and they're really performing and really, completely adopted by the industry. And the issue with virtual machines is that you have a virtualized machine with you all the times, which takes some time to boot, which has virtualized drivers, which has virtualized hard drives, which everything is virtualized. Now, over time, things got optimized. The penalty of running your programs inside virtual machines is relatively low nowadays, but still you carry a lot of baggage. So what the Docker guys have done, the Docker project has done, was to develop an engine that sits on top of bare metal, and instead of booting up an entire machine, it boots up only your application. And it isolates that application in a container. The application itself thinks it's running on an entire system, and instead it's running in an isolated, constrained environment. And it has access to a copy and write file system that cannot affect the entire bare metal machine. So this makes Docker containers boot up really fast, and you can cram a lot of applications on the machine, and that's why a lot of people are excited about Docker. That's one way to tell what Docker is in very short amount of words. So Docker, in reality, Docker command, the Docker open source project, the core, you cannot really summarize it in one paragraph. You need to use 4. So I'll tell you those 4, and then we move on. So Docker is, at the core, a format, a way to package your applications. And generally, we're talking about back-end applications, cloud applications. So Docker is also a way to be explicit and define how these applications can talk to other applications, other containerized applications. That is, you say, open these ports for this application. I need this application to access this drive. So you are explicit about the interfaces that your application needs. And third, Docker gives you a way to cache and to build incrementally your applications step by step, so that when you're rebuilding them, you don't have to redo all the steps all the time. And it does this by using a cached copy and write file system where every command you run inside your container as you build it up is cached. And fourth, Docker has a central registry, a repository where you can push your applications and you can retrieve them and you can distribute them to your colleagues or to other people that want to use your technology. And you can host a registry yourself if you want to keep it within the premises of your company. That was my 3 minutes introduction to Docker. It has been exploding in popularity, this trend of moving workloads, cloud workloads, using containers. A lot of service providers have been supporting it. Now you might want to ask, what are we? What is Atlassian doing with Docker? What do we have to do with Docker? So let me tell you very briefly what we've been doing with Docker on the product side of things and internally. I'll reveal some things also about our internal systems. The first thing we did was announcing, it was around 1.5 years ago, at the very first DockerCon, we were ready with an announcement, and that is, we thought, wow, Docker gives us an environment to deploy things really easily. So why don't we distribute our Bamboo agents on the Docker registry so that anybody who has a server where Docker is running, the Docker engine is running, they can deploy workloads for our Bamboo, our build server, our continuous delivery server. So that was the first thing that we announced. It's already been out there for a while. And if you think about it, Bamboo is the perfect platform to adopt container technologies, because building application, testing them requires you to always cache, and it allows you to, if you can cache the steps of your builds and the test results and the updated code, this allows you to skip redoing that all the times using containers. And that's why, one of the reasons why Bamboo is a great fit for your Docker testing. And actually yesterday we had a workshop about that. Some of you might have been joining that. So since Bamboo 5.8, that's exactly what we did. We made the Docker first-class citizen of Bamboo, where you now have a Bamboo task that can actually build a container, run a container, push the container to a registry, whether it is your own or a public one. And new this week, we just released Bamboo 5.9, which has a few new things in it. The ones relevant to Docker, and so to this talk, are much finer grained control over the Docker commands and the Docker tasks that you want to run inside Bamboo. So you can do dynamic port mapping. You can mount more than one volume inside while you run your Docker commands. You can set the working directory, which is a requirement for some setups and some kinds of builds. And you can pass your own parameters if you have really complex Docker commands that you want to run. This frees you from having to script your Docker infrastructure, and you can just use this out-of-the-box tooling. That's one of the things on the product side. Which other products are actually adopting Docker? So one thing we've done was a bit earlier this year was to announce our officially supported Docker image for Stash. So any customer, anybody who wants to try out Stash, you can just pull that image on a server that has Docker and spin up a Stash instance. Now, this was fairly popular, and you guys might have as the next question, okay, when is Jira going to be on the registry so that I can install Jira by pulling a container? For this, my answer is, please check. This is a perfect opportunity to grab one of the PMs, one of the product teams, and ask and tell them your need, that it's something that you'd like to see. Personally, I've been advocating this internally, but if you make your voice heard, then you might be able to, to speed things up and make this thing happen sooner. That's on the front side of things. And obviously, more work will go into refining our support for Docker in Bamboo. But we also have been adopting Docker workflows and Docker technology internally at Atlassian. So I'm really revealing today something that hasn't been told before, and that is Atlassian, like we heard before, we were like 1,500 people strong, 800 people in our engineering teams spread out around the world, though mostly in Sydney. And we have a platform an internal platform as a service, as we call micros. And that platform as a service, you can think of it a little bit like Roku for internal Atlassians, allows developers to deploy their own applications, services, either customer-facing or internal services. Now, that infrastructure nowadays is used, for example, for our file infrastructure services. We have 8 microservices that are running entirely in containers. It's immutable infrastructure that's very easily upgraded and released. And every time you upload a picture to Confluence On Demand, you are kicking off one of these containers. Every time you upload a picture, upload a movie, upload a presentation, 5 containers are spun up and process your data, so reducing the size of the images, compressing the videos, and that sort of activities. All the file infrastructure runs in containers. Just to give you a statistic about this, we checked what what was the number of containers we ran the past month. We spun up 6 million containers just the last month. And because everybody likes eye candy, this is a picture from the dashboard, the first 24 hours then that this system was in place. And then you can see it processed in the first 24 hours 45 gigs of conversions. So it's a very reliable, very solid system that runs on a very low amount of hardware because it can scale the tasks using containers. Yeah, this is just to say we're invested in Docker both externally and also we're adopting the technology internally. So that answers the question, why is Atlassian using Docker? The point of this talk, though, is orchestration, because Docker started being something to package an application and publish it, and soon people hit this wall where they wanted to Dockerize everything, and they wanted all their components of their applications to talk to each other. And you reach a level of complexity where a human typing a very long commands is something that's not feasible anymore. And so there's a big trend in Docker, but also in cloud development of cloud applications in general. There's a trend towards, orchestration frameworks. And orchestration frameworks is something that tries to remove the complexity from managing your physical infrastructure, and you describe your infrastructure to the architecture of your application at a relatively high level, and you let this orchestration framework start up machines, start up containers, linking them up, rebooting things if they crash. And there's a few of these frameworks emerging from a very, very respectable, very popular open source project. I'll mention a couple. One is Kubernetes from Google. It's a completely open source project. It runs on many services as a platforms. Obviously, it runs also on Google infrastructure, and they describe it as allowing you to manage a cluster of Linux machines as if you had a single one. And just very briefly, if you see the architecture, I just want to show a few of these charts so to give you a sense that the architectures of these tools are more or less all the same. There's a master that controls a few nodes. On these nodes, containers are deployed. There's generally a service discovery, a service that allows you to keep a list of the machines that you have available. And obviously, there's a scheduler with different policies. And this will be a recurrent theme, as we'll see. Another one, the one that many people consider the only production-ready orchestration framework nowadays, is Mesos from the Apache Foundation. It's a project that was initially started by Twitter, and it was started to support different kinds of workloads based on Hadoop, but now they have pledged support to Docker and containers as well. And if you look at the architecture of Mesos, you'll see some similarities. There's always a master. There are slaves that deploy workloads. There's a service discovery service. In this case, it's called Zookeeper, which is another Apache project. And this is the one that many people consider production-ready, already used at scale, for example, at Twitter. So it's a very robust solution. But my talk is about Docker specifically. So what I want to tell you is about what's the Docker project itself doing related to orchestration? So from the simple command line tool that it started as, they're now developing extra utilities, extra commands, extra pieces of the infrastructure to bring, help you abstract more of the physical infrastructure and help with orchestration. So Docker has three pieces recent that have been developed over the past year, and they're becoming more and more stable. One is called the Docker machine. Docker machine allows you to provision hosts with Docker installed, ready to be used. And it doesn't matter if you're provisioning a machine locally on your virtual box or VMware locally on your machine, or if you're deploying it to any of the platform as a services that are supported. There's many supported, and you can treat them as the same, whether you're on your machine or on DigitalOcean or on the Google Cloud or AWS. Docker Compose allows you to it's a slightly higher level version of linking manually containers where you describe, I have this application, web application, it requires a database. These are the ports of my applications. I want the database to be open on this port. I want the file system, the database data to be saved on this folder. And you can put everything organically together in a configuration file and bring all those services up together. And Docker Swarm is the cluster management solution of Docker that allows you to give Docker commands that instead of running on a single machine, run on a cluster of Docker-enabled hosts. And so it's a lot of words, but I want to show this to you. So let me start with the first demo as I walk to my desk with a remote keyboard. So this is what I want to show you. First, I want to start a machine completely from scratch. I pick DigitalOcean as one of the service providers, deploy a machine there, install Postgres there, install Stash, link the two together, start up Atlassian Stash on it, and then destroy the machine. And I'll show you how quickly you can do that with just a few Docker commands. So now if this remote keyboard works, switch to the command line. I apologize, the commands are a bit long, so I hope you can read them. So let's start. So to create a new machine, without having to reach and open any UI of a service provider, provided you have an authentication key, in this case called the DigitalOcean access token, I can type Docker machine create, specify that I want the machine to be created on DigitalOcean. This machine needs at least 2 gigs of RAM because I need to run Java on it, and I want to run a small database on it. So I say that the size has to be 2 gigs. And I want to call the machine Atlas Camp Standalone. And this goes to DigitalOcean using a standardized protocol of Docker machine. And I have a machine now available to me to use with Docker deployed. It was a bit fast here because I cut out a little bit of it. Otherwise, it would take 5 minutes for DigitalOcean to answer. So we're going a bit faster here. And with Docker Machine LS, I can now list the machines that I have installed locally. As you can see, I have a new one that is called Atlas Camp Standalone that runs at that IP address. So now I can just type Docker Machine SSH to that name, and I can directly SSH on that machine, and we'll try to deploy Stash and Postgres onto that machine. So we're now SSH into that machine. And what I need to do is, in general, if you start up a new instance of Stash, you need to enter your licenses. So I'm cutting a corner here and created a configuration file that allows you to enter the license information, the database information, and this allows you to skip all the initialization step of Stash. So after I've done that, I can just create the Docker Compose file that will allow me to start up Stash with the database. So let's create the Compose file together. So, okay, I need to fix this. All right, so just to pause on this is the configuration of a very simple Docker Compose file. We say we'll have an application called Stash and a database called DB. The application will run on those ports. It will need to mount those specific folders. For simplicity, I'm running it as root, which is something you shouldn't do. And that's the password for the database. So once I have these configurations done, I can just type Docker Compose, and the application will be done. So the first thing I need to do is install Docker Compose, because as the machine was provisioned, Docker Compose wasn't installed in this case. Obviously, you can provision your own images if you want and have this sorted out for you. So I'm just making Docker Compose executable. But after that done, I can just type Docker Compose -d up, and this will bring up Stash and the database exactly as I described it, as you see now. Docker Compose up -d. This will go and start pulling the official image of Postgres from the Docker registry. This might take a while. I'll speed up a little bit the download. And then it will pull out the Stash official image from the Docker registry. So I didn't have to provide anything, any code myself for this. And now I can check if the two instances are running, as you can see. And if I want to check what's happening. I'm going back to my shell. Docker machine ls shows me Atlas Camp standalone is running at IP address 188.166.7733. And maybe we can see what happens to the port of stash port. So 7990, I think that is. So open the browser, put in the IP address, add the port, and stash is starting up. So we deployed the stash using Postgres. We fed pre-fed the license to it. We typed docker compose up, and takes a bit of time to initialize the first time. And now it doesn't ask me for any license. There's already a default user created, an admin user, and I'll be good to go and use stash. So I've deployed in just a few minutes a new instance of stash on DigitalOcean. That's, I thought, already pretty impressive because it was a relatively low amount of work to get this working. Now, when I'm done, just for the sake of this test, let me show you how you destroy it. You just say docker machine rm and the name of the machine. And we just get rid of it, delete it from DigitalOcean, and you won't be built anything more from it. So I can just do docker machine rm and the name of the machine. And you see how fast it is? There you go. I've just deleted it, and all the work I've done is gone. OK, so just to summarize what you just saw, we used Docker machine to create a host, in this case on DigitalOcean. You can use any account on any path that you have. We edited the Docker compose file to explain how our application was assembled, and we only used the standard components, like an official Postgres image and the official stash image. And then by typing docker compose up -d, we started up the services. And when we were done, we just removed it. So that's already pretty impressive, but this was not very much related to orchestration. So what about orchestration that I've been talking about the whole talk? So for orchestration, to get to orchestration, I need to tell you a little bit about Swarm, Docker Swarm. If you look at the picture, you see that it's very similar to the other orchestration frameworks that I've showed before. There's a master, there are some nodes on which you deploy containers. And there's a discovery service that keeps a track and a list of which machines are part of the cluster. Now, the cool thing about Docker Swarm is that it has a lot of nice features. For example, it has strategies that allow you to decide how and where your containers, your applications will be deployed. For example, there's a spread strategy that will try to deploy the application, your applications to as many hosts it can, so spread the load. Or there's a bin pack strategy that will do the reverse. We'll try to cram as much load as possible on a single machine. There's a random one, and then obviously you can program your own. And the other very interesting things about the Docker Swarm is that it has filters. So once you have tagged your machine with labels, for example, or you can deploy workloads or applications based on those labels or based on the physical traits of the machine. Like you can say, I want to deploy this Java app, but only in a place where it has at least 2 gigs of RAM, or it will crash. So this is where you're starting to create an orchestration of services, and you deploy based on constraints, which is very powerful. So let's see a second demo. In this demo, instead of creating one machine, we create 3 machines, one master node, one node that we will tag with the label Java, because that's where we want Java to run with 2 gigs of RAM. A simple node that we will use as a database. And we'll still run Stash and Postgres, but this time we'll deploy them to a cluster just using constraints. So there's many discovery backends, discovery services that you can use with the Docker Swarm. In this example, I will use the default one, which is the one provided by the Docker registry. So you can get your unique cluster ID by just saying docker run swarm create. And that will give you a unique identifier for your cluster, but we'll do it together, so fear not. So we start by creating a unique identifier for our cluster by typing docker run swarm create. This will give us a unique identifier for the cluster. Because I want to reuse this ID a lot, I'll just put it into an environment variable called token. So you'll see that here now as I type this. Yes. So just save the unique identifier into an environment variable, and so that I can reuse it for all the commands I need to type. Next, we're going to create 3 machines. One is going to be the master of the swarm. So it's similar to the commands I gave before. I just added --swarm, --swarm master. And this will make sure that not only Docker machine deploys Docker to the machine, but also sets it up as a master of a cluster. This can take a few minutes, so we skip that. And we name this machine as Atlas Camp Master. It's aptly named. So after that's done, what we want to do is we want to create a second one. We want to create Atlas Camp 1 and Atlas Camp 2. So let's see. Now you see I have created the master, which is part of the swarm, Atlas Camp Master. I'm going to create a second machine. I need to pass the discovery token so that Docker will know, the swarm will know which machines are part of the swarm. I give it a name, Atlas Camp 1. I'm still using DigitalOcean. And this specific machine, I add a label. I add the label Java. So let me post this. So you could say engine label instance equals Java, because I want to tag that machine, the one where we will deploy stash. And after that, we can create the third machine, Atlas Camp 2. It doesn't need very specific requirements. I just want to make sure I label it that it's for the database. So as you will see another Docker machine create command with a specific swarm discovery, the same token, and then the name and label database, and we call it Atlas Camp 2. OK, we have our cluster. So if I now want to show you the architecture, how that looks after that's done. So if I do Docker machine ls, you see the list of machines. I have 3, Atlas Camp Master, Atlas Camp 1, and Atlas Camp 2, plus a couple ones of development that I've been using. And just to give you a sense of what's happening, this is what we just did. We created a node that's the swarm master with Atlas Camp 1, node 1, labeled Java, and Atlas Camp 2 machine, which is labeled database. And we're using as a discovery service the default discovery service of Docker. OK, next, let's go on with our thing. So next, I want to make sure that all the Docker commands I type are executed on the whole cluster. So I need to do a Docker machine environment --the swarm Atlas Camp Master. So this will make sure that every command I type now is executed across the entire master. If you want to see the outline of the cluster, I can type Docker info, and this will tell me, I have 3 machines, Atlas Camp 1, 2, and master, and one has 2 gigs of RAM, exactly as I created them. So now every command I give, it's actually a command given across the entire cluster, and I can deploy things on these machines using constraints. So for example, as you see, I'll now start the Postgres server on an instant that is labeled as database. So I'll just start a very normal Postgres image that opens port 5432, that has a certain password, and that will be started on the Atlas Camp 2 machine. All right, and if I do Docker PS, you see that it's actually really running on the Atlas Camp 2 machine. And now I can start stash. Before I start stash, you remember, OK, I want to note down the IP address of that machine, and that's for something I need to tell you about. And that is, we need to set up stash so that it points to the right database. We will be able to automate this, but for the sake of this demo, I'm doing it manually. I'm logging on to now the Java machine. So I'm just going to do, sorry, I have a slide for you, intermediate, to show you what's happening. So we just deployed Postgres on Atlas Camp 2 node. And now what we do is we first configure stash on the Atlas Camp 1 machine, and then deploy stash to it. So, all right. So second part is we want to log in 1 second to the Atlas Camp 1 machine so that we can configure stash so that it doesn't require a license, and that we point it to the right database machine. So I do exactly the same thing I did before. I need to add one configuration file called stash config, and in the stash data shared folder. And this will allow me to skip all the initialization of a stash the first time I run it. So the only thing I need to change is the IP address of the machine that's running on the cluster, which I skipped. I'm sorry, it was too fast. So now I want to start stash and just saying deploy to wherever I can deploy Java applications. So Docker machine, I have a list of the machine, and now I can finally run stash onto it. Right? So I just say run stash. The constraint is that it has to run somewhere where I tag the Java. I need to, because I'm not using Docker Compose now, I need to be explicit about the volumes I am mounting. So I need to tell to mount the folder where I store that configuration onto the default root directory where stash runs. And after I am done, this will be deployed, hopefully, onto the Java instance. So now if I do Docker PS, you can see our stash instance has been deployed on Atlas Camp 1, and our database instance has been deployed to Atlas Camp 2. And if this was successful, I can go and check what was the IP address of the stash instance, and we can check if it's booting up as I imagine. OK, type IP address, the port. OK, it seems it's starting up. Very nice. And again, this time, we haven't deployed it on a single machine. We have actually deployed programmatically, using constraints, stash to a cluster. Now, we can further automate this. There's some limitations right now with Docker Compose that forced me to go and edit that file manually. You'll be able to link containers across a cluster just with some configuration file. But this is what we just did. We deployed stash using labels to a node in the cluster, and we deployed Postgres to another one. And yeah, I find this incredibly exciting. There's a lot to talk, a lot of development going on into this, a lot of still polish and still work to do so that it becomes properly viable to all developers. And if you want to know more about this, you want to chat about this and ask questions, feel free to come and talk to me or Steve during one of the breakout sessions. There's one specifically for Docker stuff. And with this, I want to thank you very much for your attention. I hope you found this interesting, and hope to catch up with you later today. Thank you.